right, this is our first notes. So I'm going to show this during our Google Meet. If you haven't written this down yet, pause and just copy everything. This is how I want your notes to be set up. Basically, every time we take notes in math, you should be having a title. And I'm going to try to number them. I think that's going to help us stay organized. I want your name, date, and period. I want the essential question. I'll probably always give you the essential question. So for today, this is notes number 1, basic review. The essential question, how do I use PEMDAS, evaluate expressions and combine like terms, CLT. The essential question guides the whole notes. It's like, what's the point of notes today? Well, read the essential question and that tells you what you're going to learn. I do believe Cornell note style is the best way to learn. So for sure, especially when I model it like this, use Cornell note style. And then I'm not always going to give you questions, but I'm just kind of modeling it so that you know what to expect. You don't have to number them, but I think it helps students to see like, oh, number 1 question here, and then you'll see when I move the paper, how to do the second and third question. There should be 3 questions per page of notes. So this is a little problem. It's like order of operations. We're going to do this in the Google Meet. I'm going to project it, and then at the end of our meet today, we'll solve it. So for right now, it should just kind of not be, well, we'll go over it, but if you want to give it a try, you can. So anyways, here we go with the notes. Again, pause whenever you need to so that you can get caught up. So I'm going to go ahead and slide this up. You can see I put a little number 2 for the question right here by the hole punch. The second question relates to this chunk of information, like this middle chunk. The first question relates to this chunk. So think about chunking your page into 3 sections and having 1 question per section. So again, pause as needed, you guys. I'm just kind of going to go through this, and I already pre-wrote a lot of it so that I wouldn't take the time on the video to do that. So order of operations, PEMDAS. Again, I didn't really mention this. You should have different writing tools. I like highlighters, different colored pens, pencils. So far, my notes are written in pencil, but I could have written them in pen. I wanted to make sure it was dark enough, and my pencil seemed dark enough. So anyways, I like to highlight a lot. Order of operations, PEMDAS. It stands for parentheses, exponents, multiply, divide, add, subtract. You can add whatever you want to these notes, like to help you learn. We're going to go through order of operations in the problem from above. Parentheses usually look like that, but brackets and braces also count. They're just kind of telling you what to do first. Always do the innermost, which would be parentheses, and then work your way out, but always do the innermost parentheses. Exponents would be like if I have 5 to the second power. 5 to the second power means 5 times 5, 25. So you would do exponents after you do inside the parentheses. You would multiply, which, it could be shown like with a dot, 7 times 2, 14. Multiply and divide from left to right. Divide maybe like 25 divided by 5. Remember, division and multiplication, they can be written several different ways. Like I can have 6 times 4 with parentheses, but that counts as multiplication, not parentheses. The parentheses means do what's inside the parentheses first, if there's addition or any other operation inside. And division, maybe it could be written as a fraction. 14 over 2 means 7. Divide it, okay? So just remember what all that stuff is. I know you know this, but it's been a while. Then you add and subtract from left to right. So I'm not really going to go over that too much. That's pretty basic. So add and subtract from left to right, okay? So what you'll do after all your notes, go back and do a question here. Right now, you shouldn't really have a question. Right now, you're focusing on the learning and copying the notes and learning from the problems. And again, add to this whatever might help you. All right, so we're going to go on to the next thing. I don't want to show too much. We'll show this part for now. So I wanted to talk a little bit about integers. And by the way, this is all based off of your assignment number 1 in ALEKS, ALEKS, when we do our ALEKS assignment. So it'll have some questions in that assignment about integers. So this is what integers are. Integers are positive or negative whole numbers and 0. So I usually tell my students, just think of the number line. Any number that you see right here on the number line is an integer. So, and the arrows means that it keeps going. So it keeps going past -4 to -5, -6, -7, and forever to infinity, to negative infinity. So every one of those whole numbers that's either positive or negative or 0, they're all integers. And again, you guys pause this as you need to get caught up. Here is some practice. This is very similar to what it will be like on ALEKS. I'm going to zoom this in. Hopefully it works. You should be able to see this. Okay, so it's a question, yes or no, are these integers? So I would pause it right now if I were you. Pause and write it down. All right, so hopefully you paused and wrote this down. These are each one is either yes or no. We have 4, -3, 2/2, and so on. So I'm going to first read this little part at the side. It says, so if it's a fraction that divides evenly, like 49/7 equals 7, then it is an integer. So let's think about it. If we do see a fraction, but it actually could equal a whole number, either positive or negative, then it would be an integer. Oops. Okay, so let's just go through and see. So 4, well, yeah, 4 is on the number line. Yes, it's an integer. -3, yeah, it's on the number line. Yes, it's an integer. 2/2, 2 divided by 2. That does divide, that equals 1. Yes, that is an integer. -10/5. It's a fraction, but I can divide it. It would equal -2. Yes, it's an integer. Okay, but this one, 13 divided by 2, I cannot divide it. It would equal like 6.5 if I did divide it. And you guys can use calculators whenever you want to. That would be a no. Any decimals would not be an integer or a fraction that you can't divide evenly. So -1.3, well, that's also no, not an integer. All right, so again, pause as you need to, and I'm going to just keep moving on. Okay, so write this down, and I'll just start going through it. Pause whenever you need to. So this is the next part. Can a number be written as a decimal? So you're going to have some questions in ALEKS about this. If the number is a terminating decimal, that means it stops. It does not have the ... after the last digit. So an example would be 5.3342. So that does stop. It stops at the 2. This 2 is the last digit. I forgot that I was going to write underneath this. I'm going to make this a fraction. So I am going to just squeeze it right under there. So what I can do to write it a fraction, if it does stop, if the decimal stops, I just have to count how many places are there after the decimal, and that's how many zeros are on the denominator. So that's a 1. So like, it's either going to be like 10 or 100 or 1,000 or something like that. So there's 1, 2, 3, 4 zeros. 1, 2, 3, 4. I don't like the way that looks. I'm going to write it one more time. 53342 over 10,000. And again, I'm sorry, I didn't plan that out very well. I kind of forgot. So again, if the decimal does stop, you can write it as a fraction. Try it in the calculator. Does that equal the same thing we started with? Then you'll know for sure, like, oh yeah, that does work. So this is a yes, terminating decimals. If you forget what that means, highlight the stops. Okay, the next thing, a repeating decimal. So if it's repeating the same number or pattern of numbers, then it is, yes, it can be written as a fraction. I think I wrote the question wrong. That's embarrassing. Okay, this happens sometimes. Can it be written as a fraction? Sorry, guys. Okay, so just like me, you'll probably have that little mistake. It's okay. All right, so a repeating decimal, like this one right here, I'm going to point 0.333 dot, dot, dot. I put right here this little note. Dot, dot, dot means that it keeps going. So the next digit would be a 3 and then a 3. Whatever number is there, it keeps going. So that is a repeating decimal. That's a yes. This one right here, 0.292929 dot, dot, dot means it keeps going. So the next two digits would be 29 and then 29. It just keeps going. That's a yes. This has, I just want to show you, it could have a number in front of the decimal. This is just 6.5444. That's going to go 4444444 forever and ever. It keeps going. So that's a yes. Okay, so my notes stopped here on this page. Whenever you need to go to a different page, do it. So I'm just going to turn my page over and then set it up again. Again, you guys pause as you need to. So you might have to go back and pause if you weren't done writing. So then I'm not writing on the back of the pages because it kind of gets a little sloppy. Sometimes things bleed through, especially using highlighter and pen and different things. So you'll figure it out as you go if you don't like that or if you don't care. But for today, let's just write it on a separate sheet of paper. And then I did the title again, and you could even do, I think having the date here would be a smart idea. All right, so anyways, set it up Cornell note style. You'll have questions on the left, notes on the right. This is the same thing continuing. So pause it if you want to, write it down, and then you'll listen to the explanation. Okay, so the other thing you'll see sometimes, you'll see a bar on top of the repeating digits, and I wanted you to know what that means. The bar goes across whatever repeats. If it's only across the 4, only the 4 repeats. So here it's 0.65444 dot, dot, dot. It's the same if you write it like this. The one that had 2929 repeating, it would have a bar going across only the 29. And that is a yes. If you have the bars on top of a decimal, like, let me just highlight the bar talking about is like that. If you have the bar, then that would be a yes. That decimal can be written as a fraction. And again, you'll have questions like this in your ALEX assignment. The only time so far right now that we are saying no. A decimal cannot be written as a fraction. If decimals neither terminate, so they don't stop, nor repeat, but they do have the dot, dot, dot. So you would see the dot, dot, dot after, but you're like, oh, there's no bar, there's no repeating, and the dot, dot, dot means it keeps going. So all of these are examples of a no. No, these cannot be written as a fraction. Okay? I'm gonna just write that. You guys should hear that. So they cannot be written as a fraction. Okay, last part for the notes. And again, you guys please pause as you need to. You can go at your own pace on this, which is pretty neat. Keep in mind I have my number 1 and 2 for questions on the right or on the left. Okay, I'm gonna move it up. The last thing is combining like terms, which I know you've learned this. It's all review, but it's been a little while, and hearing the explanation again, especially from a new teacher, is good. That way you kind of get how I teach and how I explain things. So combine like terms, CLT. I like to take a shortcut if I can and use abbreviations, so get used to CLT, combine like terms. So when you combine like terms, and again, pause when you ever need to and just write this down and then listen to the explanation. You add or subtract the coefficients, which are the numbers in front. Always take the sign in front. So if it's like negative 3x, it's a negative 3, like a minus 3. And then just in case if you don't know, like terms are terms that have the same variable. Like terms have the same variable or letter, same. Like means same, and then the variable determines if they're like terms. So I just have a few examples. Again, you guys please pause, write down what you need to, and then you can continue with the explanation. That way it's not like, oh, hold on, miss. You know, you can just go at your own pace. So I think this should work really well for you. All right, so the first example, I'm just going to use a pen to circle the coefficients. Coefficients are the numbers in front. So for my example, 3m minus 7m equals negative 4m. The reason is because we have like terms. We have the same variable, so I can combine them. I would do 3 and then take the sign in front. 3 minus 7, that would be negative 4. Okay, so that's how you would combine like terms. On the next example, I have 3 terms. Each one of those is a term, and they all have a C. So I can just look at the variable, look at the letter C, C, and C. I just add and subtract whatever is in front. 10, and you can go from left to right. 10 plus 5, 15, minus 2, 13. And you only keep it just a C. Don't try to be like, oh, there's 3 C's, so it's C to the 3rd power. I've seen that mistake. It just stays C, 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 so 13C. That's the variable. Give these examples a try. So pause it if you haven't solved them yet. Give it a try. All right, so now I'm going to go over these examples. I hope you gave it a try. This first one, I can see the variables are both e's, so I just have to combine 16 plus 7. So 16 plus 7 is 23, and then I keep that same variable e. All right, the next one. I have 32x minus 45x. Anytime I have a smaller number taking away a bigger number, I know my answer will be negative, but then I just have to subtract 45 minus 32. So I can do that in the calculator, I can do it in my head if I'm not good, or just to be on the safe side, I'm writing it down. 5 minus 2 is 3, 4 minus 3 is 1, so 13. And like I said, it's negative 13 because it's a smaller positive number taking away a bigger number. And don't forget your variable. I got to put my x there. All right, the next one. I have 3 terms, 1, 2, 3, but that's okay. I'm looking at the variables. I see p, p, p. They're all p's, so all I have to do is combine the coefficient. Always take the sign in front. Always take the sign in front. If there is no sign in front like the 13, it's positive. So I just go left to right. 13 minus 5, that is 8. 8 plus 7. And again, you could use the side part for scratch work if you need to. What did I say? 8 plus 7, so 15. Don't forget the p. And that should be good. All right, and then, yes, this is the very last example. We are almost done. I've got a p term, but then I have a q, and then I have a p. So later on, when we get going with more problems, I'll show you guys. I would circle the p terms, always get the sign in front, and like maybe do a triangle over q terms and do a box. So if there's like s terms, like if there was some with an s. But for now, I'm just going to combine. You have to combine the like terms, those two. Combine means to add or subtract. So I have my 22 plus 4. 22 plus 4 is 26. P, but I can't forget the q term. So there's a plus 3q. I just have to add that plus 3q. And then I can just kind of check it. Does that seem right? I have 2 p terms, 1 q term. Look at my answer. It seems right. Okay. One last thing, you guys. At the end of every note, so like this is note number 1. If we have a note number 2, you need it at the end of that one. We need a summary. Not on every page, a summary for every note. So this was one lesson. I need one summary, which I require 3 sentences. We might share these out in class the next day we have class. So be ready for that. So it says summary, 3 sentences. You can start it off however you want, but just to get you started, you can say, today I learned. What I would recommend is go back to your essential question and review your notes. What did you learn about? You learned about PEMDAS, evaluating expressions, and combining like terms. You could get specific and say, what is the order of operations? You could say, how do you know a number can be written as a fraction? So again, look through your notes. You can say, today I learned how a number can be written as a fraction. And there's 1, 2, 3 ways that it's a yes, but 1 way that's a no. So you can just re-emphasize that. You could summarize combining like terms. There's a lot you could write about in your summary. All right, so by the time you are done, you should have all the notes, all the examples, and then you can write your summary and your questions. And that should all be done within 24 hours. So for sure, by the time we have class, that should all be done. All right, thank you and good luck.